Today and across the fence, maple researchers at UVM are sweet on a new crop, but it's not the one you're thinking of. And we check in on an annual rite of spring that requires a good flashlight and a set of waders. Good afternoon, and thanks for joining us. I'm Keith Silva in for Judy Simpson. Science is the never-ending search for knowledge. For every question that gets answered, 10 new questions get asked. Scientists at Proctor Maple Research Center knew they could tap birch trees, but when to tap, what temperature to boil at, and how to tell if it was done, those answers didn't come easy. It's taken several years, but some answers are starting to sugar off, which means more questions. Let's learn what's been boiling up at Proctor Maple Research Center in Underhill.
With the steam blowing outside and the evaporators boiling inside, it looks like an ordinary sugaring day at Proctor Maple Research Facility in Underhill. With one exception, this isn't maple.
We are actually boiling birch sap into syrup in our processing research facility.
Birch trees start producing sap about the time maples stop. Abby Vandenberg first started researching this project in 2011. This is the first crop of birch syrup produced at Proctor.
These are really the first modern experiments in commercial maple or syrup processing equipment that have been done to look at those questions, so to try and find what different practices and techniques actually make flavor that is sort of most preferred, that kind of thing. So, and yes, it is the first time that we here have boiled birch sap into syrup in commercial equipment. We've done small scale stuff before, but this is the first time that we've done it in our 3x10, actual real evaporators.
As for the taste, remember, this isn't maple.
Birch syrup has, in many ways, almost savory characteristics, almost, I want to say, spicy and kind of a lot more intense. You can look at it and see that it is syrup and maybe have an expectation that it might taste like maple or some kind of table syrup, but it is very, very different than that. It does have some flavors that are similar to molasses, but it's also very unique and sort of its own special thing.
The taste of birch differs from maple because the sugars are different. For Vandenberg and fellow researcher Mark Hisselhart, this means recalibrating all the instruments common to sugar makers.
Birch sap is predominantly made of glucose and fructose, or what we call invert sugar, as opposed to maple sap, which is predominantly sucrose. So sucrose and invert sugar are two very different things, and all of our instrumentation for measuring density in maple syrup and maple sap and sugar content, things like that, even the temperature that we measure, all of those are calibrated to pure sucrose solutions. So everything that we do for birch has to be adjusted to the fact that we're working with invert solutions. So we really have to basically develop not new tools necessarily to measure the syrup that we're making and the sap that we're processing, but develop calibrations for those tools to use specifically with birch, and that's one of the things that we're doing as part of this research too.
Across the Fence first reported about Vandenberg's birch research in 2013. At the time, boiling sap was a long way off. First, she and her colleagues had to figure out when birch trees needed to be tapped.
We have no idea when to tap birch trees. None. It's really, there are a lot of really simple questions like that that we don't have good answers to.
If maple syrup is considered a niche or a specialty product, then birch syrup is a niche of a specialty product. Out of the tree, birch sap looks exactly like maple sap. And like maple, birch syrup is used as a sweetener. And that's where these two similar saps sugar off and go their separate ways.
Birch tends to be a little darker, but it is brought up to approximately the same density that maple syrup is. So it has a lot of the same look, but has a very distinct flavor that really, is nothing like maple syrup. So it's really not appropriate to compare the two. They're really, they're sweeteners, but they're two very, very different products in themselves. So they might look a little of the same, but they really don't taste the same at all.
Most of the world's birch syrup production comes from Alaska, and the supply is limited, which is one reason Vandenberg is interested in tapping into this market.
Right now, the price for pure birch syrup is about $74 a quart. So it's a very valuable commodity, both because of its limited supply and also because it's very difficult to produce in general to produce well. And the demand for it is particularly heavy in the international markets. Then there's also the local food market. It's the local chefs that really want the product. So if this really goes forward, it would really require some work to kind of develop those markets and foster both of those types of markets to make sure that it's a product that people would buy once we start producing it.
Marketing birch syrup is putting the cart before the horse. Until then, Vandenberg and her colleagues need to solve the minor problem about when to tap.
This tree here is one of our test trees. We've learned from other people who produce birch syrup that in order to get the most out of each tree, you need to tap it just at the right time. In maple, you're able to hedge a little bit, tap early, and not really lose out on the total production. With birch, it's important to get it just right. So we have a number of trees that we tapped just to watch the sap flow and to see when it was really running. And when the majority, about 75% of those test trees are running, then we were able to start our experiment.
So far, researchers have determined that birch sap starts to run about the time sugar maples have stopped running. The purpose of this study investigates if sugar makers in the Northeast could diversify their operations after the maple sugaring season. Sugar makers would essentially switch their taps from maples to birches.
So we are tapping a set of 40 birch trees of tappable size and a range of diameters and collecting the sap from them and measuring that sap to determine what is the volume of sap that is collected from each of those trees. And we also measure their sugar content. So at the end of the season, we can calculate the average quantity of sap and sugar that is able to be harvested from birch trees in our operation. So then we'll use that average yield to do some economic calculations to determine, okay, given an operation with a certain number of birch trees and a certain functioning of their maple operation, certain equipment, etc., how many birch trees would you have to have in order to make birch syrup production a profitable venture?
This research is funded by the Northeastern States Research Cooperative. What Vandenberg and her funders are banking on is that modern sugaring technology, like reverse osmosis, which concentrates the sugars in the sap, will increase the amount of birch syrup that can be produced. On average, the sugar content of maple sap is about 2%. Birch sap tends to be about half that, and often even less. Vandenberg estimates that it could take at least 100 gallons of birch sap to make 1 gallon of syrup.
We really didn't have a way to make birch syrup profitably in the Northeast before. The lower sugar content, the lower sap yields really just didn't make it, a winning proposition before. And so that is one of the reasons that it hasn't been, the line of inquiry hasn't really been pursued that heavily before, other than sort of just from a purely scientific standpoint, looking at why the pressure is produced and things like that. So now we have these tools and techniques and technologies that enable us to say, well, perhaps we could make this a profitable venture. So, all the resources that we've had developed from doing research in maple, we're able to apply what we've learned to birch.
This project is designed to study sap yields and correlate profitability, not make syrup. One of the hallmarks of applied science is that every answer generates 10 more questions. Like those researchers who came here in the late 1940s, Vandenberg and her colleagues are learning more than what they set out to do.
We're kind of curious as to exactly how and why birch trees are doing what they're doing. It's a different sap flow mechanism than maple. A maple sap flow is based on a stem pressure mechanism. Birch sap flow is based on root pressure, so it develops in a different way. So we are doing some measurements of the pressure inside birch trunks across the season, in both tapped and untapped birches, to see how the pressure develops, and also trying to link that with air temperature and soil temperature and things like that, so that we can get a little bit of a better handle on exactly how pressure develops in birches. That will kind of inform our decisions of, okay, so if we're going to tap birch trees, when is it best to tap them, how early, how late, things like that. Some of those sort of management type questions that we'll need to eventually answer a little better than we know now, if this turns out to be a profitable venture.
Oh, wow.
This monitoring station, built by researcher Mark Iselhart out of a cooler, keeps all the electronics warm and dry. His ingenious efforts are being rewarded with some new data that only Mother Nature has ever known.
Trees that we have wired up for pressure and temperature are giving us readings of the internal pressure in the tree. And we know from the literature that the tree can develop quite high pressure, as high as 30 psi or higher. What isn't well known is what the pressure is in a tree after it's been tapped. So we actually have a tree, several trees wired with sensors to measure the pressure in the tree, and we also have one that has a tap hole in it that we're collecting in a bucket. So we're able to get, really for the first time, what the pressure in the tree is when it has sap flowing out of it.
It all boils down to being very curious and interested in how trees work and what they do, how they do what they do, and sometimes why they do what they do. And this is just another piece of that, another problem or question under that umbrella that is really fascinating to look at and investigate.
A lot has changed since 2013. Birch syrup has gone from $74 a quart to over $100. The birches that Vandenberg was testing didn't produce enough sap to keep the experiment in-house. So like any scientist, Vandenberg had to adapt and overcome.
The producer that has sold us the sap will get the syrup back. Since it's so incredibly valuable, we couldn't possibly afford to pay them for it. So they get the syrup back so that they can sell it and still have that value for them. Once the season is over, we will analyze those samples, of course, for the chemical composition. We'll do experiments to hone in our density measuring equipment with them. And then we will, most importantly, conduct sensory evaluation experiments. And that will help us basically get some information, first and foremost. And it will also help guide next year's experiments. We have 2 years to do this. So what we learn this year will help us guide and choose treatments that we may use for next year. And so hopefully at the end of 2 years, we'll have a really good idea of what a birch producer needs to do to make syrup with really consistently good quality.
High quality syrup from a highly scientific process.
Our next story is another rite of spring, the migration of reptiles and amphibians. To talk about what's creeping and crawling out of hibernation and into Vermont's ponds and wetlands, here's herpetologist Jim Andrews.
The amphibians have been spending the winter either underground below the frost line or right in the leaves, where some of the species, 4 of our species, can actually just freeze and thaw, which is an amazing thing, that their hearts can stop and their lungs can stop and they can freeze and then thaw out, just add water and a little heat, and then they have to head downhill to get to those pools and ponds and beaver dams to lay their eggs. So there's a big rush of those early breeders, wood frogs and spotted salamanders and Jefferson salamanders and blue spotted salamanders that all need to breed really early. It's an early sign of spring. It's kind of a rite of spring. It's an early passage. And sadly, for the amphibians, many times there's a road between where they're coming from and the pond that they're trying to get to. And if there's a lot of traffic on that road, there can be a fair amount of mortality. So people really like to get out and help them across the road and just see that early spring migration.
What's the process for tracking these migrations?
You look for these spots where there's good overwintering habitat on one side of the road, breeding habitat on the other, and you walk those sections of road at night, let's say 8:30 or so at night, maybe a half hour or so after sunset, When you walk the roads, you may go up and down that particular crossage area with a nice, good, strong flashlight. I mean, even if people don't know the species they're seeing, that's still useful information. It tells us where a crossing area is. But even better is if they snap some photos. You know, I saw a few of these, I saw a few of these, I saw a few of these. You don't have to know what they are, but if people can get some photos and give them to us, then we can know what they are.
Thanks, Jim. The Vermont Reptiles and Amphibian Atlas is on the web at vtherpatlas.org. There you can contribute tips, photos, and find out where to look for all creatures, small and slimy. They're also on Facebook. Search Vermont Reptiles and Amphibian Atlas. I want to thank everyone here at WCAX for making today's program possible, and as always, thank you for stopping by Across the Fence.